All right, we're recording now. So exercise 13A, we're going to begin with revising your index laws. There are 8 of them. Most of the students that I've seen in the past through my experience, you will remember the first 2 really well. Here's the first 2. Number 1, this is what you have. A to the power of m times a to the power of n. I'm just going to write it over here. And I'll probably press enter. Here we go. 1 and 2 you'll remember. So a to the power of m multiplied to a to the power of n. You add the 2 powers together. That's number 1. Number 2, a to the power of m divided by a to the power of n. You know it's minus. Minus the 2 values. That's pretty straightforward. What comes that I find mistakes? I'll show you some mistakes here. In fact, I saw it in your SAC, in your exam as well. Some of you, when you do something like this, like that, okay, I see a lot of students when it comes to algebra, to expand this, what you do is you do this. Why is this wrong? And there was a time that this was okay. Because I can see why students are doing this, and it's based on the fact that you don't understand rule number 4 really well. Why is it that this occurs so often? As a marker, I see this all the time. When it's x plus 2 squared, I see x squared plus 4. Why can't you do it in this example, and yet you can do it in this example? If I give you, that's a 3, and you can say this. Why is this okay, and these 2 you can't? What's the key?
One's a plus.
Very good. What's the difference between the 2 that most students don't see in the rule? You see here, this is a times b. That's saying a times the b to the power of n. You're saying that ab is one term. But in this bracket over here, this is not one term. This is x as one term, plus 3 is the second term. That's 2 terms. So you can't say, oh yeah, based on what I remember, cube the first one, cube the second one, which is what most students do. Whereas this one, this is okay. This is okay to do because 3 times x is 3x. That's one term. That's why it's okay to say, yep, I can cube these terms individually, and it's because it's times. So this is the first mistake that I often see, and that's with division and multiplication. That's rule number 3, rule number 4, right? Rule number 5, most students will know. That's your a to the power of 0 equals 1. What's a common mistake? Something like this. What's the answer?
Minus 3.
Minus 3, very good. What's the common mistake you think people would do?
1.
Very good. This is not the correct answer, and why? Why do you think they're writing 1? What are they thinking?
It's minus 3x as a whole term.
Very good. And to show that, this is what they're thinking. Well, why don't students do that? Because students don't generally put in brackets. When you're writing your notations, how often do you use brackets? That shows in your layout. That's why I can see when in year 10, year 9, if your layout is poor, I can see what your mistakes are. And the same thing when you guys start learning logarithms, most of you will start writing something like this. And I'm going to teach you to not do those kind of things, to actually put in the brackets. And most students don't. We're lazy to do that. But those brackets matter because there is a difference between this and that one. This should equal to negative 3 times x to the power of 0. That's why the answer is negative 3. Whilst this one, that's equal to 1. Okay, so that's the difference between the 2 there. What's another common mistake? This one. Let me give you another one. Simplifying this, what does this become? Or maybe I should just use letters actually. I'll use letters. What does that become? Say it again. Good. Oh, another thing to mention there, sorry. You can just leave your answer here. In year 12, never leave your answers with negative powers because examiners always want to see positive powers. So their final answer would be b5 over a squared. Okay? What about if I gave you this one then? because that often comes up too. And then I'll see the struggle between the algebra here. So what would this be?
1 to the power of 5 over 1.
Say it again.
A to the power of 5 over 1.
A to the power of 5 over 1.
Could be the other way around. Or is it? It's minus 1. What? 1 over A over 5.
Which one?
Second one.
Second one. And how do we show that? How do we know? Very good. This symbol here, that means divide. What you have to realize is this is a term together. Another way of writing it to help you, it's 1 divide 1 over A to the power of negative 5. We know that A to the power of negative 5, like you've shown to me over here before, is the same thing as writing A to the power of 5 over 1, and you've got that. So when you're dividing fractions, remember you're doing the reciprocal and it becomes multiplication, so it's 1 times 1 on A5. That's why the answer is 1 on A5, okay? But that is an example of what I mean as an algebra. I just threw out something that is a typical one that often challenges the average student, okay? Here's your last two rules that I find that students tend to forget, and it's probably worthwhile writing. Anyone know the rule for, what does that equal to? Matt?
Isn't the n insert, the n is outside and the n is inside?
Like that? Very good. This here is what students don't realize. You see that denominator of a fraction? We call them rational indices. They're called nth roots. What students don't realize, when you write square root of a, this is equivalent to saying a to the power of half. Okay, so if you didn't know that, that should be part of your notes. And so often when I see students, and came into your algebra as well, what's the opposite of a cubed? How do I get rid of the cube? It'll be 1/3 or cube root. And this is where I saw in one of your exam questions, okay, this is cube root, which is the same thing as a to the power of third. In your exam questions that you did, there was a part where it was something like this. Most of you got up to this step. I can't remember the exact question, but it was something like this, something like that. And then you guys did it all correct up until this point. How do you get rid of a cube? What's the opposite of a cube? Cube root, or like what you were doing here, to the power of a third. So if you chose to do it, you should have done to the power of a third on both sides, or cube root both sides, and this is what I saw. Most students left it as 1 to the power of a third, or cube root of 1, and you had 4x minus 2, and you had no idea how to solve that. And this tells me that you either didn't understand this section, evaluating it. What's cube root of 1? 1. So most of you should have been able to go to the next step and said, add 2 on both sides, that becomes 3 equals to 4x, therefore x equals to 3 on 4. But because you couldn't do this first step, you were stumped here, hence algebra. Okay, so that kind of skill there, that what I'm highlighting there, is another one that comes back to indices. How strong are your index laws? Now there are 8 of them. Most of you will remember the first 2. Students are generally pretty good with 1 and 2, and they're good with the power of 0. What do most students struggle with? It's the one with the negative power, so a to the power of negative m equals to 1 on a to the power of m. And the reason why, I think it's fractions. Students hate fractions. And same thing with a to the power of m on n. Why do students hate this one? Again, it's fractions. You've got fractional powers. Students don't like fractional powers. These are the 2 most common rules that you will be using in year 12, and even the SACs that you'll be doing. Those are very common. So these are the types that I will be looking for to know how well your algebra is. I'm not looking at this. You see, if I wanted to give you easy marks, that's what I do. I start giving you things like 3a squared times 4a5, and I say, what's the answer? But that's because I'm giving you marks. When I want to challenge you, I'll be looking at skills that are most often that students make mistakes. So the ones that I showed you before, any of those to the power of zeros, anything to do with 1 on 1 over a to the power of negative 5, these are things that I'm testing you because I want to see if you can do algebraic equations. Okay? Now, you've got your 8 rules. Hopefully most of you got some refreshment on that and you kind of remember some of the rules. Let's try a question together, and I want you to do this one first in your own exercise book, and then I'm going to write the solutions up and see if you've got the correct one. But let's go with B. Okay, so I want you to write down B. I want you to lay out your question, your method, and your answer. Show me what you would have done, and then I'll show you my solutions so that you can figure it out. Okay, so copy the question down. I want you to have a go with this one because I know students don't like negative powers and students don't like fractions. So then we're going to work on it. You're going to have to love fractions. You're going to have to love negative powers because the state hates it. If the state number of students hate it, then you can go beyond them. Learn to love it. Learn to practice fractions and negatives. The better you are against the state. Most students in the state hate it. They suck at it. They struggle with it. So if you practice it, you get better than them. Well done the question, have a go. Doesn't matter if it's wrong or right, I'm more interested for you to learn how do you lay it out, what are some of your misconceptions, what are some strengths, because whatever you find that you aren't good at, this is a good exercise for you to revise. When I give you my year 10 test, that'll be a good time for you to understand what's the expected level that you should have mastered by 10. Because these are all skills from the junior mathematics course. Skills that we need to practice. Skills that are very common. Just write down the question. Your aim is to simplify. And I got one more problem to challenge you after this. One more problem to challenge you.
Okay, I was just going to do one more. This is going to be such a big one.
Each and every one of you might have a different approach, but you should all get the same answer. Some of you will simplify it quicker. Some of you may use alternative methods to make it easier. And then I'll show you how I do it. My tip is always make it easier for yourself. Whatever you don't like, get rid of it. So in my mind, I know students don't like fractions. Get rid of the fractions. How do you get rid of the fractions? If you get rid of the fractions first, then maybe it's easier. So a lot of times, as an example, a lot of students convert that b negative 1 into a fraction. Why do it into a fraction when you hate fractions? Don't do it. Just leave it as it is. Change it at the end.
You're going to be an astronaut now. So like 6 months ago, you wanted to be in the army, now you want to be in the
I don't want to get it now. Just, you just go. I just want
want to shoot it. That's it.
You know what's the funny thing is that might be part of your psychological test that they do. Want that? My cousin failed his psychological test and couldn't join the army because one of the questions asked, will you shoot whatever the army, and he said, depends if the person, like if I was instructed or not. The answer is, I want to shoot them. And he didn't say that, They want loyal soldiers. They give you an instruction, you go follow. You don't question, you do.
I mean, it's like, if it's just some random guy and he's trying to kill people, obviously I want to shoot him. But if it's just some civilian or some child, obviously I'm not going to shoot him.
They don't want to hear that.
Well,
hey, they want to hear that if you tell them.
No, yes, 5-year-old baby. I mean, is that 5-year-old baby going to kill someone else? If that 5-year-old baby was going to grow up to be Adolf Hitler, I would shoot it. But you never know.
As in the war, there was my dad was in there during that Vietnam War, and he was escaping. But in the nearby village, there was the Americans who like trying to figure out which Vietnamese to like are the northern versus the southern.
Yeah.
They found civilians in that area, and it was a question of should we kill them because they've now discovered our hiding spot. And there was young children and women. And at the time they said, no, that's just immoral, we can't do that. And so those people went back, and they're actually spies. They were just walking around to scope and scout. So they went back and told the village that there's these American soldiers out here. So what they should have done, which was feels wrong, but they should have killed that. Which is interesting. It's once you're in war, it's a very different.
China is growing. There's a reason.
Yeah, that's the reason I'm not being nice to you guys.
Did I get it right? I'm sorry, guys. So you could simplify that once.
So is it A9?
No. That's not simplifying.
Because 2H, A9, B3, B6. So
Did I get that?
A9, B6 divided by A3, B3,
To
C9.
start as an 8. No.
Am I right?
This is A6. Look, A6 is where you are. That's A6. Divided by A6 is A3. Yes. Divided by D.
I would say that most of the challenge would come from here. I can see that being a problem. I think most of you can see where I got A3 from. A6 divided by A cubed, we know we minus the power, so 6 minus 3 gives you 3. This is where it might have been tricky. B cubed divided by B negative 3.
So that would be B6, because like minus it is.
Yeah. That is a 6. It's poorly written 6. But essentially, yeah, you're right. That would be B to the power 3 minus negative 3. See, I don't need to bring the B up. You just do exactly rule number 2. Rule number 2 is 3 minus the negative 3. Double negatives is positive, so B6. That's how I got B6. And then the one on the bottom, C6 times C3. Add the powers, C9. Okay, so find ways to make your problem easier. You can see I tried to remove as many terms as I can in the first one, and then I cubed each one is times. Cube of 2, 2 times 3, 3 times 1, 3 times 2. And then I just use the same rule again, division, do the reciprocal. I kept it as it is, and I used rule number 1 and rule number 2. So I kept everything simple. I don't try to make it harder than it is. Don't try to add in fractions. You can see in my 3 steps, I just went exactly what I saw. Okay? So where you made mistakes, if you did make any mistakes, have a look. Why did you make those mistakes? What rules did you misconceive? or what sort of techniques are you using that's making it more difficult? Okay? Let's have a look at the next one. Next example and the last example for today. How would you simplify now, out of these two, which one do you prefer? B or C? Which one would you like me to do?
B.
All right, let's do B.
C looks harder. Oh no, C looks harder.
C looks harder? B looks harder because of all the negatives?
No, C. What negatives is kind of like because you gotta change the A to a.
Maybe I'll do both then.
B just if it's a negative, just flip it up to the top.
I never flip it unless I really have to. Because flip makes them into fractions, and unless you're really strong with fractions.
It's already in a fraction, so it doesn't really matter. So if you flip it.
Oh, you mean like, oh, I see what you mean. Oh, yeah. Sorry, I thought you meant as in flip it and leave a fraction on the numerator.
Oh.
So some students will do this where that is like that.
Oh, no. Just put it at the bottom. Put it at the bottom.
Correct. And that's where not all students generally know. So when they see this, they get pretty nervous. Have a go with this one. How would you simplify it? This is a typical year 12 generally type problem. CAS calculator. Which is why you're so strong at it. Definitely something that this class is really good at. Your CAS calcs. It's pretty good. It's not cheating. You actually need to be really good at it. If you can apply that CAS and in exam 2, then I'm really proud of you all. That'll be great. Yeah. But it seems like the application sucks because your algebra is poor. That's why. So algebra is poor. It's not the theory. You get the theory. You're just not applying it. So if you can build on that, that'll be really good. Here we go. So I'm breaking them into what we call prime factors, because then you can find common factors using the index laws. I can then expand those and break them out of their powers. So you can see the 6, I broke it up into 2 times 3. 12, I broke it up into 3 times 2 squared. And then the 9, I broke it up into 3 squared. If you were able to pick on that idea, then the next steps is all about simplifying. So here we go.
Pretty sure there isn't my class.
What's 3 to the power of 6?
3 to 6, that's like
Like 712.
720.
No, it's not.
729. I have 3 terms. I can get it right, but it's still smacking.
Oh, 729. You were so close to it.
Yeah, because the low was distracting me. I was such a low-hit moment, low-hit. Let me go to the definition of a low-hit moment. She just had it for like one side, but she was like so
Oh, you're right, there is no negative. There was a negative here.
she's been like 4 years.
She got her degree from University of
I only have like 4.
This is how I would have done it for those who were sort of watching. Break it up into your prime factors, expand the brackets, and this is where you should be okay with after you've got this. So all I did was I collected them using rule number 1 and 2. When you times, you add the powers. So I did -3 plus 4 minus 3, and then minus and -8 is what I did, collecting all the bases together. And then I did the same thing for the 2's. 2 to the power of 4 plus -6 minus the -2. That's what I wrote here. And by simplifying it, I now get 2 to the power of 0, which is 1, and you end up with 3 to the power of 6. So that's how I would have done it rather than changing them into fractions. I just kept it as it is. And that's how I approach it. Doesn't mean you need to, but you can see I try to minimize the number of fractions I work with. I try not to flip things around. I just stick to what I have, and I use rule number 1, rule number 2 very consistently, just so that it's less steps, less mistakes.
So that took a while actually. Would we have to be doing it like mega fast, like in like 10 seconds or something?
Well, in your exams you won't get something like this. You'll more likely get something like this, but with logarithms, and your idea is to be able to take the first step. So as long as you take the first step. So have a go with this one. This is now C, 3 to the power of 2n, same theory, 6 to the power of n, and 8 to the power of n times 3 to the power of n. So if you understood that last example, you should be able to do this, and it should be less complicated because there's less negatives. So you should be able to get your answer, break them into their prime factors, and you should be able to do the same for this example.